Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and this is a Decision Maths A-level video, and it's the first video on linear programming. So in this video I'd like us to be able to work on a particular skill. So it's to draw inequality regions graphically. Now I'm not going to introduce what linear programming is all about just yet. I just want us to work on some basic skills so we can access this chapter. Everything in here should be GCSE, but we're going to go through it. So for example, I'd like us to be able to draw the region bounded by the inequalities 2x is bigger than or equal to 3y, 3x plus 4y is less than or equal to 24, x is bigger than or equal to 3, and y is bigger than or equal to 1. So I'd like us to plot those inequalities on a graph and show the region bounded by all those conditions. So let's start nice and simply. Example 1. Now I'd expect you to be able to do these already, but let's just go through each one step by step. Sketch the region given by the inequality x is bigger than 2. So what we want to draw is we want to draw the line x is equal to 2, and we want to draw this with a dotted line. Okay, so the line x is equal to 2 would be a line like there. Every point on that line has a x coordinate being 2. So for example, here is 2, 2, and here is something like 2, 8. So this is the line x is equal to 2, right? But we want to draw the region x bigger than 2. So what we do when we have an inequality and a strict inequality, by strict, I'm going to just call this strict here so you know what I mean. This is a strict inequality. It means x can't be equal to 2. We draw a dotted line to demonstrate that. So we're going to draw ourselves a dotted line. So I'm firstly going to make that line there, and then I'm going to make it dotted afterwards as follows. Okay, and there we go. And now if we want the region x is bigger than 2, we want everything here where the x coordinate is bigger than 2. So the convention is to shade the region you don't want. So what we're going to do is we're going to shade this whole region here like that. And we're going to state in here that this is the region we reject, and this is our region here. So we're going to just tick that to say that's the region. So everything in there is x bigger than 2. Right, next example. Let's draw the region bounded by the inequality y is less than or equal to 2. So here we don't have a strict. It's not a strict inequality. Not strict, because y can also equal 2. So we're going to draw the line y is 2, but this time it's not going to be dotted, it's going to be a straight line. So y is 2 is along here, because every point along that line has y coordinate 2. We want y less than or equal to 2, so we want the region below that line. So what we're going to do obviously is we're going to shade the region above the line like that, and we're just going to state here that we rejected this bit, and this is the bit we want. So everything below or on the line is y less than or equal to 2. Just to make it clear there, that drew itself a little bit funny. This should have gone down to here as well. And we're done. Now a little tip before we start complicating things. They were the easy examples. X bigger than 2, so everything here, and y less than or equal to 2, so a full line and everything below there. Just a little tip for you to write down. If you want to sketch a region in the following forms, and by this form I don't mean it has to be less than or equal to any of the combinations here at all, it doesn't matter, and similarly any of the combinations here, it doesn't matter. If they're of the form y inequality mx plus c, or if they're in the form a y plus bx is less than or equal to c, that's the best form to put them in. So make your inequalities be in that form, and then if it's less than, it's below the line. If it's more than, it's above the line. Here, similarly, if you've got it in this form, if you have a less than inequality, you're looking below the line, and if you have a more than inequality, you're looking above the line, if they're in one of these two forms. So if they're not, it would be a good idea to make them in those forms. Just to make it clear what I mean, say if you had something like y is less than, let's say 2x, okay, something like that, and you wanted to draw that, all you'd have to draw, because it's in the right form, you draw the line y is equal to 2x, you'd make it dotted because it's a strict inequality here, so you'd make it dotted, and you want below the line because you want y less than 2x, so you want below the line, so you shade above the line, and that's your ignore, like that. So if they're in these forms, it's nice and simple. Similarly, if you wanted to draw something like, I don't know, x add y is bigger than 5 or something like that, you would draw that. It's because it's in that form, you would draw that, and how you do it is you just would say x is 0, y would be 5, and similarly if y was 0, x would be 5, and you draw your line. This time you want a dotted line again, so you draw a dotted line. Because it's in the form we talked about, some y's plus some x's, I perhaps should have just written it like that just to make it absolutely clear it's in the right form. Because we want above the line here, we're going to shade below the line, and that's the region we reject. Okay, so we want above the line. So there's a little tip for you. So with that in mind, let's have a go at these questions. Let's sketch the region given by the inequality 4x add 3y is less than or equal to 12. So the first thing we're going to do is, it's in the form we're looking for, what we could write it as 3y add 4x is less than or equal to 12, like that, just to swap it around the right way so that the y is first, but it doesn't really matter. Now we want to draw the line 3y add 4x is equal to 12. We want to just firstly draw that line. And the way we're going to do this, we're going to suppose x was 0. If x was equal to 0, then we would have that 3y is going to equal, that should be the 12, 3y would equal 12, and that would mean that y would be equal to 4. Similarly, if we set y to be 0, then we would have ourselves that 4x is equal to 12, and we would have that y is therefore equal to 3. So we're going to plot the 2 points 0, 4, and we're going to plot the point 3, 0. That should have been, sorry, that should have been x was equal to 3. So we plot the point 3, 0, we plot the point 0, 4, which is here, and we're going to draw that inequality. Now it's not a strict one, so we're going to have a straight line, not a dotted line, so let's make sure we've got that, something like that. Okay. Okay, and we want below the line, so what we're going to do is we're going to shade above the line the region we don't want. So we're going to shade above this line here like this, and we're going to reject that section, and we're done. Next example. Now you should be able to get on with these yourself by now, but I'll go through each one. By all means pause the video and do it yourself if you feel you can. We want to sketch the region given by the inequality 3y is bigger than x. I'm going to just rewrite that as y is bigger than a third x, dividing both sides by 3. So I want to draw this line here. Well, if I set x to be 0, in this y would also be 0, and if I set x to be something like, I don't know, 9, let's say if x was 9, y would happen to be equal to 3. So I'm going to use those two as my starting point. There's 0, 0, and I'm also going to plot 9 against 3, 9 with 3, and there we go, we've got my region there, something like that. Okay, now it's of the form y mx plus c, so we want y bigger than that, so we want above the line, so what we're going to do is shade below the line like that. Now do you spot one deliberate error I've made, just to see if you were concentrating? This was a strict inequality, so of course this should have been a dotted line. So make that a dotted line like that, and we're done. Right, next one. Let's sketch the region given by the inequality x is less than or equal to 2y. Now, it's not currently in the form y mx plus c, let's say. So let's just rearrange it so y is the subject. So let's rewrite the inequality the other way around. 2y is bigger than or equal to x, so that y is bigger than or equal to half x. And we're in a very similar position now to how we were before, and we can just plot it without worrying now. So let's plot the line y is equal to a half x. Well, if x was equal to 0, in this case y would equal 0. Let's pick an x that you can halve. Let's make x equal 10, let's say, and y would equal 5. So let's use this to plot our points. 0, 0 is here, and 10 goes with 5, just like that. So we could use that to plot our line. Now this time, we don't need a dotted line because it's not a strict inequality. Now, do we shade above or below? We want y bigger than or equal to, so we want above the line. So what we're going to do is we're going to shade below the region we reject. Like that. Next one, we're going to do 5 examples, and now we're going to start combining them. So we're going to have a region bounded by the following inequalities. So we want x bigger than or equal to 2. Okay, so x is 2. And we want bigger than or equal to 2, so we don't want a dotted line, we want a full line, and we want bigger than that side, so we're going to rub out all of this side here. Like that. So we've done that one. Let's maybe do some of the easy ones. We want x and y bigger than or equal to 0. Now, because x is bigger than 2, it's certainly bigger than 0, so I'm not too worried about that. But we want y bigger than or equal to 0, so if that was our line here, y equals 0, we want above that line, so what we're also going to do is we're going to say that we don't want any of this either, below the line. So we've done 2 of them. Now let's do the in-between 2. Let's go for this one. Let's try and draw that line there. So we're going to have 4x plus 3y is equal to 12. We're drawing that line. So let's let x, if x was equal to 0, then we'd have 3y is equal to 12, so y was 4. And similarly, if we put y to be 0, we'd have 4x equal 12, so x would be 3. So we're going to use the coordinates 0, 4 and 3, 0 as our determining region. So 0, 4, 0, 4 is here, 3, 0 is here like that, and we want less than, and so we're going to need a dotted line, so let's have a dotted line here. Just have it like something like that. Okay, and we want below the line, so we're going to ignore everything above the line. So we're going to ignore everything above this line, which would be here like this. So you can see we've only got this tiny little region here at the moment. The last one, we want 2y less than or equal to x, so we want y less than or equal to x, half x. So what we're going to do there is we're going to clearly say, well, a pair of coordinates are x is 0 and y is 0, and maybe something you can divide by 2, x is, let's say, 10, and y is going to be equal to 5. So 0, 0 and 10, 5, which would be like that. And we want less than or equal to, so a straight line, we want it to be a full line, not a dotted line, just like that. And we want less than or equal to, so we want below, so we're going to shade everything above. So here. So basically, this is the only region we've got left. If you can see the region we've got left there, I could colour the whole lot in, but there's no need to. I could colour the whole lot in, but there is the region we're going to have R, and we would call that region R. Now, a little thing that I should have done as I go along, I should draw these lines. This is the line clearly y equals 0. This is the line x equals 2. This line here, that was the line 4x plus 3y is equal to 12. And this line here was the line y is equal to a half x. So you should label in your lines as you go along as well. But there's the first region. Right, let's have a go at another one. This one here. Let's do the easy one. first of all, the bottom one maybe. We should start off there. We want x bigger than or equal to 0 and y bigger than or equal to 0. So we're going to draw the line x equals 0. We want a full line here. So we're going to draw the line x equals 0 and we're going to draw the line y equals 0. And we want everything where x is bigger than 0, so we ignore everything where x is less than 0. And we want everything where y is bigger than or equal to 0, so we ignore everything where y is strictly less than 0. So already we're up in this top quadrant here. Right, let's go for another easy one. Let's go for this one here, y less than or equal to 5. So let's draw the line y equals 5. We want it to be a whole line because it's not a strict inequality. We want y less than or equal to 5, so we ignore everything above here. So we're going to ignore that. And as we go along this time, let's write our equation. So that was y equals 5, this was y equals 0, and this was x is equal to 0. So we've done that one, and done that one. Now we want y is bigger than x. So we draw the line y equals x, which is quite easy. It goes through 0, 0. As it goes up 1, it goes along 1. It's just that line there. We want a dotted line here. Okay, we want a dotted line. Like that. Okay, and we want y bigger than x. So we want above the line, so we're going to shade everything below the line. So we're going to shade this thing here below the line here. So we're getting left with that triangle so far, apart from the last inequality we need to do. So let me just write in y equals x there. So the last one we're dealing with is 2x add 3y is equal to 18. If I let x be 0, this would mean 3y was 18, so y would be 6. So we'll plot 0, 6. Alternatively, if I let y be 0, I'd have 2x is 18, so that x is equal to 9. So I'd plot 9, 0. So I could plot 9, 0, which is here, and I could plot 0, 6, which is here, and I could draw a line between them, which must be a dotted line, because it's a strict inequality. So I'd do something like that. I want above the line, it's of the form ax plus by is bigger than or equal to that, so I want above the line, so I'm going to shade everything below the line. So I'd shade this here. And you can see now that our region is this thing here, that triangle, which is hard to see, but I'll label that R like that, and we're done. Okay, 3 more examples. Again, feel free to do these yourself without watching me go through them, but check at the end you've got them right. Okay, easy ones. Let's draw this one. X bigger than 3, y bigger than or equal to 1. Strict lines, so y equals 1 there, and x equals 3 there. Okay, so label those in. X equals 3, y equals 1. We want, in both cases, we want x bigger than or equal to, and we want y bigger than or equal to. So we're going to shade everything below the line, what we don't want. So we're going to shade all of this here. Yeah. And we're going to shade all of that there. Now, each of the 2 left over, and this one's quite an easy one, so let's just get that one done out of the way. 3x add 4y is equal to 24. Let's try and draw that one. Now if I let x be 0, I'd have 4y is 24, so y would be 6, so I'm going to plot 0, 6. On the other hand, if I let y be 0 here, 3x would be 24, so x had to be 8. So I'm going to plot 8, 0. So 8, 0 is going to be, 8, 0 will be here. So would be here, and 0, 6 is going to be there. And I join those up with a straight line and a filled in line because it's a full line. So I've drawn that there, and I want below the line, so I'm going to shade above the line. So I'm going to shade all of this above the line here. Okay, so we've got a triangle so far. Let's see what the last inequality does. Now the last one is this. So it's we want a 2x bigger than or equal to 3y. Now I want it with y in front, so I'm going to rewrite that as 3y less than or equal to 2x. And what I'm going to do here is I'm going to say that's y is less than or equal to 2/3 x. So clearly that goes through 0, 0. Because if x is 0 in this y would be equal to 0. And let's pick something that, let's pick an x you can divide by 3. Let's pick x to be 9 or something like that. And 2/3 of 9 is 6, so y would be 6. So it clearly goes through 0, 0. And it also goes through 9, 6. So 9 across here and 6 up here, like that. And we're going to draw a fill-in line here, so a full line, just like that. We're looking down at this one here. We want below the line. We're going to want below the line, so we're going to shade everything above the line. So we're going to shade this section here. So that leaves us with that triangle there, and that's our region R. Okay? And that should be enough now for this video. We've done several examples there. What I suggest you do is you have a look in the book, you read through those examples, and you do exercise 6b to finish off. Thanks loads for watching.